You fire up your scraper, point it at a site, and instead of data, you get this. A plain gray page. Pardon our interruption, maybe just access denied. No error code that makes sense, no explanation, just a wall. That's Akamai. And if you've ever tried to pull data from Amazon, eBay, Airbnb, or SimilarWeb, you've already met it, whether you knew what it was or not. In this video, I'm going to break down exactly what Akamai is, walk you through every way it detects your scraper, and show you step by step how to set up a clean browser profile that gets past it, starting from zero. No prior experience needed whatsoever. The best solution for Akamai. Watch this till the end. I'll show you a complete clean scraping setup for Akamai protected sites, how to keep your IP and browser fingerprint clean so you don't get blocked, and how to get 2 GB of free proxies to start extracting data with way less risk. So what actually is Akamai? Akamai is a company that provides web services to thousands of major websites. One of those services is called Akamai Bot Manager, basically a bouncer that sits in front of a website and decides for every single visitor whether they're a real person or an automated script. If it decides you're a bot, you get the wall. And look, it's not some simple on-off switch. Akamai doesn't just check one thing and make a decision. It runs you through a multi-stage evaluation and builds what's called a trust score. Think of it like a report card. Every signal it collects about you either adds points or takes points away. Drop below a certain threshold and the block fires. The reason this is so hard to deal with is that there are 4 separate layers feeding that score. Let's go through each one so you actually understand what you're up against. Checkpoint. Akamai is a bot detection service that rates every visitor with a trust score across multiple layers. Layer 1. TLS and JA3 Fingerprinting. The very first thing Akamai checks happens before you even load a page. It's called a TLS fingerprint, basically the unique signature your browser leaves during the encrypted handshake it does when connecting to any HTTPS website. Think of it like a knock pattern on a door. Every browser knocks differently. Chrome knocks one way, Firefox knocks another way, and Python's requests library, which is just a popular tool for fetching web pages in code, knocks in a way that looks nothing like any real browser. Akamai reads that knock and knows immediately, this isn't Chrome, this is a script. The specific identifier it checks is called a JA3 fingerprint, named after the researchers who developed the technique. This is Akamai's most effective detection vector. It can fire on the very first connection, before you've even made a single request for data. The reason this works as a detection signal is that every programming library has different encryption capabilities, and those capabilities produce a distinct pattern. A real Chrome browser and a Python script are completely different on this layer. Layer 2. IP address classification. Next up, your IP address. An IP address, basically your internet connection's home address, the unique number that identifies where requests are coming from, is classified into 3 types, and Akamai knows all of them. Residential IPs are addresses assigned by internet providers to real homes. Akamai treats these positively because real people use them. Mobile IPs are assigned by phone networks to mobile users, also positive and harder to track because phone towers often share and recycle IPs. Datacenter IPs are addresses assigned to servers, Amazon Web Services, Google Cloud, that kind of thing. And Akamai has a huge database of known datacenter IP ranges. If your request comes from one of those, significant negative score. Flagged. Most simple scrapers use the same IP for every request. Even if the IP is residential, sending too many requests from one IP in a short window triggers Akamai's rate detection. Think of it like a bouncer who notices someone walking in and out of the same door 50 times in a minute. Layer 3. HTTP versions and headers. Here's one people miss. HTTP, basically the protocol, the language that browsers and websites use to communicate, has different versions. Modern browsers use HTTP/2 or HTTP/3. A lot of scraping libraries still default to HTTP/1.1, an older version. Akamai checks which version you're using. HTTP/1.1 is a bot signal. On top of that, Akamai checks your request headers, basically the extra metadata attached to every web request that tells the server things like what browser you're using, what language you prefer, and where you came from. Real browsers send specific headers in a specific order. Scrapers tend to either skip headers entirely or send them in the wrong order. Akamai notices both. Checkpoint: 3 detection layers down: TLS signature, IP class, HTTP version, and headers. One more to go. Layer 4. JavaScript fingerprinting explained. The deepest layer is JavaScript fingerprinting. JavaScript, basically the programming language that runs inside your browser to make pages interactive, can be used by a website to collect detailed information about your device. What graphics hardware you have, what fonts are installed, what OS you're running, what your screen resolution is. All of that gets combined into a unique browser fingerprint. Your browser's full ID card, not just the knock pattern, but the entire profile. The honest trade-off here: reverse engineering Akamai's JavaScript challenge to fake this data is extremely complex. Akamai's team updates it constantly. The practical answer is to use a real browser where the fingerprint is already real and control it from the outside. That's exactly what an anti-detect browser does. Don't worry, the name sounds more dramatic than it is. An anti-detect browser is basically a modified version of Chrome that lets you create multiple separate browser profiles, each with its own distinct fingerprint, its own unique canvas signature, WebGL rendering, fonts, audio stack, so each profile looks like a different real person. It also integrates directly with Proxies, so each profile gets its own IP. The tool we're using for this is GoLogin. How to identify an Akamai block. Before we get into the setup, let me show you what Akamai actually looks like when it fires, so you recognize it. The most common version, you get an HTTP 403 response. That's a standard access denied status code, and the page shows either "pardon our interruption" or "access denied" with a reference number in small text at the bottom. But here's the sneaky version. Akamai sometimes returns a 200 response, the code that normally means everything is fine, here's the page. But the content of the page is still the error message. Your scraper reads 200, assumes success, saves the response, and you don't notice until you open your output file and it's full of "pardon our interruption" text. That's called a soft block, basically a silent block designed to fool automated scripts. Your scraper thinks it won. Quick mini case: an SEO specialist tracking competitor rankings on a major retail analytics platform. They used a standard Python script with a Datacenter proxy. The first few hundred requests returned 200 status codes. They assumed everything was working. When they opened the output file, every single row was the Akamai error page. Hours of runtime, 0 usable data. A simple Iphey check before starting would have flagged the Datacenter IP and saved all of it. Safe and ethical scraping practices. Real quick before the setup, stick to publicly accessible data. Check the site's robots.txt, basically a file every website publishes that says which pages bots are welcome on. And be aware of the terms of service. Don't hammer servers with requests, and don't scrape personal data without a legal basis. Pros know this stuff and mention it in passing. Now you do too. Why user agent spoofing fails. Let me knock out 2 misconceptions before we go further, because they trip up a lot of beginners. Myth 1. I'll just spoof my user agent header, and Akamai won't know it's a bot. A user agent is basically the text string your browser sends to identify itself, like Chrome 124 on Windows. Here's the reality. Akamai checks your TLS fingerprint, your HTTP version, your JavaScript execution environment, and your IP class. Swapping a single header string while leaving everything else unchanged is like putting a name badge that says human on a robot. The shape is still wrong. Myth 2. Datacenter proxies are fine for any site. Here's the reality. For low protection sites, maybe. For Akamai protected targets, Datacenter IPs carry a built-in negative trust score before you've done anything else. You're starting the report card with a failing grade on the IP layer. Step-by-step GoLogin setup tutorial. Alright, let me show exactly how I set this up in GoLogin. Open GoLogin and you'll land on the main dashboard. You'll see a list of profiles in the center, and on the top left there's a bright green button labeled Add Profile. Click that. A panel slides open on the right side of the screen. At the very top of that panel, there's a field called Profile 1. Type anything you want, for example, Akamai Test 1. It's opened in a section labeled Proxy. There's a few buttons showing GoLogin Proxy, as well as Your Proxy and Without Proxy. Go ahead and click on Your Proxy. You'll notice HTTP appears in the summary list on the right side of the page. That's because GoLogin automatically recognizes it as the standard proxy connection type. You'll see three fields below: host and port, login, and password. These come directly from your proxy provider's dashboard. Just copy and paste them in exactly as given, or just select any saved ones. For Akamai targets, you want residential proxies, IPs from real home internet connections, not server IPs. That's the right IP class for Akamai's trust score. Here's something that trips people up. You might notice there are fields for time zone, language, screen resolution, and OS. Don't touch any of them. GoLogin reads your proxy IP, figures out what country it's in, and automatically sets all of those values to match. You don't have to configure this manually. GoLogin handles it so your profile looks like it genuinely belongs to someone living at that IP's location. Now scroll to the bottom of the panel and click Create Profile. Your new profile will instantly appear in the list on the main dashboard. Find it in the list, and on the right side of that row, click the green button labeled Run. After a moment, a green button labeled View will appear. Click that, and your isolated cloud browser window will open up, fully configured and ready to go. A browser window opens. It looks exactly like Chrome. That's normal. That's the GoLogin profile running. Checkpoint. Profile created, proxy loaded, browser launched. Next, verify it actually looks clean before touching the target. Verifying your browser profile. Once the cloud browser opens, head straight over to iphey.com to test our setup. As you can see, we got a perfect score. All 5 key indicators, browser, location, IP address, hardware, and software have green check marks. Our location is correctly showing France, and our residential IP is fully trusted. If any of these boxes ever show a red flag for you, just follow the tip on the screen. Sometimes a forced cache reset is all you need before hitting Restart Test. But with all greens here, our browser fingerprint is perfectly clean and ready to bypass Akamai's security seamlessly. If you scroll down, you'll see a breakdown of the deep dive tests Iphey just ran automatically in the background. You don't need to click anything here. These 6 boxes are simply a status breakdown showing you exactly how you passed. On the top row, it confirms your fingerprint check, IP check, and VPN checker are all secure. And on the bottom row, you can see that you successfully cleared the bot check, DNS leak test, and IP blacklist test. Scroll all the way to the very bottom, and you can see the exact raw parameters confirming this. Under the location and hardware tabs, it shows our residential IP risk score is sitting at a perfect 0, and under the bot section, critical flags like has WebDriver and has Navigator are completely false. GoLogin has perfectly masked our automated setup to look like a real human user. A clean Iphey result means you've already neutralized the biggest detection layers before you touch the target site. Honestly, skip this verification step and you're flying blind. This takes 30 seconds and saves you hours of debugging blocks. How to avoid proxy bans and errors. 3 rules to keep close when you're working with Akamai protected sites. If your Iphey check shows a WebRTC leak or a fingerprint mismatch, don't proceed. Close the profile, go back to GoLogin, delete it, and create a fresh one. A bad fingerprint at this stage means a first request block on the target. If you're hitting Akamai and getting 400 threes even with a clean residential proxy and green Iphey, slow down significantly. Add randomized delays between requests, meaning a random wait time, not a fixed one, because fixed intervals are themselves a bot signal, and reduce how many pages you're loading at the same time. Akamai's behavioral layer is watching the rhythm of your session. If your responses look correct, status 200, no error, but the data looks weird, like prices all showing the same number or listings repeating identically, suspect a soft block. You're probably seeing Akamai's cached ghost version of the page. Switch your proxy to a fresh residential IP and slow your pacing. Residential versus data center proxies. Real talk. Residential proxies are slower and more expensive than data center proxies. That's the honest trade-off. You're paying for clean IP reputation and a positive trust score contribution. If you try to cut costs with data center IPs on an Akamai site, you will spend more time debugging blocks than actually collecting data. On Akamai protected targets, residential proxies aren't a luxury. They're the entry requirement. Managing multiple profiles securely. Now, if you're scraping an Akamai protected site where you also need to be logged into an account, a marketplace dashboard, a subscription platform, here's what changes. You need one isolated GoLogin profile per account, and that profile must always connect through the same residential IP every session. Never swap IPs between accounts. Never use the same profile for two accounts. Cross-contamination, mixing IPs or profiles across accounts, triggers Akamai's behavioral layer at the account level, not just the IP level. Fast troubleshooting guide. Proxy not connecting in GoLogin, double-check the host, port, login, and password from your provider's dashboard. Copy-paste, don't type, or just select a proxy. Iphey shows red flags after launch, regenerate the profile. Don't try to fix individual fingerprint settings manually. Just create a new one. 429 responses on the target. A 429 is the too many requests status code, basically the site telling you to slow down, reduce your request rate, and add delays before retrying. Blank or ghost-like responses, new residential IP, slower pacing. Get 2 GB free proxies and 40% off. Let's bring it all together. Akamai runs you through 4 detection layers: TLS fingerprint, IP class, HTTP version and headers, and JavaScript fingerprint. Each one feeds a trust score. Drop below the threshold and you hit the wall, either a clear 403 or a sneaky ghost 200. The fix is a real browser profile in GoLogin with a residential proxy, verified clean on Iphey before you touch anything, slow human-paced requests, and knowing what the failure modes look like so you can react fast when something changes. If you want to replicate this Akamai scraping setup to get 40% off and claim the 2 GB free proxies, click my link in the description or the pinned comment. It's right there. See you in the next one.